Hi everybody, Reinhardt here. Today I'm going to go over how to classify points, lines, planes, and angles. Now most of you have learned about this in 6th grade, so this should be somewhat of a review. There are a few things that are a little bit more difficult in this lesson that I really want you to focus on, is the naming principles as well as complementary supplementary angles. I know you touched that in 6th grade. Vertical angles, and then using this knowledge to find any missing angle measures. So today, before the end of this lesson, I would like you to be able to identify and label points, segment, rays, lines, angles, either right, acute, obtuse, and plane figures. Identify complementary and supplementary angles, know the difference between them. Identify vertical angles, and use all of this knowledge to find any missing values in angle measures. So let's get started. You should have with you a piece of paper to take some notes on, and make sure you put the lesson 7.1 on the top of it along with your name, so if you were to lose it or misplace it, that you can use it on your test and assessment, and it will help you better understand the concepts. So these are all the vocabulary words that you will need to know. There are a lot of them, and we'll go through all of them. So please make sure you pause the video as you see a word to write it down, or fill it in your notebook so that you can use that. A point. Now, a point is just what it says. It names location, and we use the word point, and we name them. So if you saw something that looked like this, you would actually write out the word point A. If you saw a point that had a different letter next to it, like a B, you'd have to physically write the word point, P-O-I-N-T, and then the letter B. You always want to make sure your letters match. Pause the video if you need to write this down, otherwise continue. A line. A line is a perfectly straight line that extends forever in both directions. The key concept here is that you have to name them in alphabetical order. So you look at your letters that are on your line, you just use 2 of the letters. Sometimes you'll see multiple points. You might see another point in here that has a different letter like X. You just name 2 points, so you could either call this line BC and you use the line symbol above it. You could also call it line BX because B is a point on this line and X is a point on the line, and BX is alphabetical. Or you could name the line CX because C is a point on the line and X is a point on the line, and in alphabetical order they're named like this. So many different ways to name them. You just need to make sure they're in alphabetical order and that above your capital letters you have a line that extends in both directions. Arrows have to be on both ends. Feel free to pause if you need to. A plane is just a perfectly flat surface that extends forever in all directions. You can name it many different ways. You can either take the points that are here and label them in alphabetical order, call it plane DEF, or there will be a cursive letter somewhere on the shape, and you could also name it like that, plane, in this case, P. A line segment, or a segment, is just a piece of a line between 2 points. So you might see it with arrows on both ends, or one that comes off like this, or something that looks like that. The segment is just the piece between 2 points. They are also named in alphabetical order, so you look at your letters and you sing the alphabet, A, B, C, D, E, F, G, and so forth. What comes first? G comes first, so I write that first. H comes next, and the symbol is just a line segment. It doesn't have dots, it's just a line that goes over the top of it. It has 0 arrows because it doesn't go on for an infinity, it's just the blue section. A ray. A ray is just a piece of a line that starts at one point and extends forever in only one direction. So there's bad pun, one direction, right? Only in one direction. So you could have multiple lines intersecting each other with different points, and we could name many different rays. So let's say that's an A and that's a B. This is a ray, KJ. They are not in alphabetical order. They do not follow that rule. It starts at a vertice or a vertex, endpoint, no arrow, and it goes to the arrow. So you name it KJ. Another one we could name, let me get a highlighter here, and we could name the point B to A, and it goes in that direction, that one direction. So we could name that as ray. Notice how I put the ray symbol first, and I start with where I started. Where is my endpoint? B, and the arrow goes to A, so I could call that ray BA. There's also another one hiding in here. Let me get a different color here. This point, this point A also goes towards an arrow over here. So I could call that ray And notice how the ray always points to the right. Ray A, B, because B is where the arrow is. A is where the point is. Notice how I don't have a dot there though, it's just AB. I cannot say JK because there is no arrow, but if there was an arrow here, then I could say ray JK as well. Sometimes pictures have many, many, many different rays. All you have to do is know that it goes from point, endpoint, to arrow, not alphabetical. That, my friends, is a ray. So you should be able to pause the video here and name 4 points in the figure and name a line in the figure. Go ahead and hit pause and then check your answers. Oh, sorry. How'd you do? Awesome. Did you make sure you wrote the word point first? That's usually where kids mess up. And the lines need to be in alphabetical order with the line symbol above them. See if you can name the plane. Use any 3 points, or you could use all the letters if you'd like. Call it plane R or JKL. You have to write the word plane in front of it. For segments, just remember that your segments have to be in alphabetical order, and for rays are not in alphabetical order. Start at the end point. Go ahead and pause the video and see if you can do that. All right, these are the segments that I came up with, and the rays. They don't have to be in the same order because they're just in the picture. Let's continue. So now we're going to talk about angles. The angle symbol looks like this. It kind of looks like the lesson sign. It's formed by 2 rays that are just put together with a common endpoint called the vertex. We measure angles in degrees using a protractor, and when naming angles, we always put the vertex is the middle. That's the dot where they connect. That one always goes in the middle. Always, always. So for example, here are some pictures. If I wanted to name some angles here, all I would need is 3 letters to do so, or a number. I could name this angle right here as angle 1, or I could use the letters, and I have to use 3 letters always when naming the angle, so the angle symbol. And then this one is the only one that has to be in the middle. It has to be in the middle. And then I usually name them alphabetically. So I look at what comes first, X or Z. X comes first and then Z. And that's the way I do it, just so that we can all be on the same page. Technically it does not matter, except for this middle one has to be in the middle. And since a lot of other things have alphabetical rules, I usually just do alphabetical. For example, this one has no numbers. So this one, all the angles that you're naming here have to have K in the middle. So I could do FKG, or you can name it angle GKF. That's this guy right here, this acute angle. And then I have an angle here, GKH or HKG, and this angle HKJ or JKH. I also have GKJ, JKG, FKH, HKF, and a straight angle FKJ. A lot of different examples. We'll get more into it next. So things you've learned about in the past: right angles measure 90 degrees. If you see a right angle, they will have this little box in there. That little box means 90 degrees. Acute angles, cute little ones, are little. They measure less than 90 degrees, up to, from 0 up to 90. Obtuse are angles that are greater than 90 degrees. So they can go in either direction, but it's bigger than 90. Complementary angles are 2 angles that have a sum that add up to 90 degrees. So if you were to draw a 90-degree angle, just like that, and split it in 2 or more, the angles that add up to 90 are called complementary. So in this case, I'm just going to put a 1 and a 2. Angle 1 and angle 2 are complementary because they add up to 90 degrees. Supplementary angles measure up to 180. So if you make a straight line and then divide it into 2 or more angles, those angles added together are called supplementary because they add up to 180 degrees, or a straight angle. This is a right angle again. A reminder that is that the symbol at the vertex, it means 90 degrees. See if you can name a right angle in the figure. Notice that there is no little box here, but it is labeled with 90 degrees. Okay, did you say angle TQS? Remember, Q had to be in the middle. And 2 acute angles again are less than 90 degrees. Go ahead and pause the video and see if you can name them with 3 letters. Your letters might be in different orders. You might have said angle PQT, or angle SQR, and that's okay as long as the middle letters are the same. Two obtuse angles means it has to add up to 180. Sorry, under 180, over 90. So, give you a hint. How would you name that? Are those the two that you got? Again, your order might be different. You might say PQS or TQR. Rock on, let's go. Complementary angles, again, are the angles that add up to 90 degrees. How I remember the difference between complementary and supplementary. C in the alphabet comes before S. So when you go to an angle, if you're drawing an angle, 90 degrees comes before 180 degrees. So angles that add up to 90 are complementary. Angles that add up to 180, or a straight angle, straight starts with an S, are supplementary. Complementary. See if you can do it. Since those add up to 90, they're complementary. And supplementary add up to 180. Those would be an example. So are those. Congruent figures have same size and shape. Symbol for congruence is this guy, which is read congruent to. Intersecting lines that form pairs of vertical angles. Vertical angles are always congruent. I'll show you an example next. So in this figure, vertical angles are straight up and down from one another. So this angle, angle 2, right across from angle 4, they're congruent, and they're also called vertical angles. Vertical angles, cut by and transversal, are always congruent. So they have the same angle measure. And just for an example, 1 here is the same as, look across the way, 3. That means they're exactly the same. If you're given one measure that says this is 37 degrees, you can automatically know angle 3. And then, look at these two. They would add up to a straight angle. They're supplementary. They add up to 180. So how would you find angle 2? Oh, exactly. You'd subtract it. 180 minus 37. Oh, that means angle 2 is 143 degrees. Well, if this one's 143 degrees, what would 4 be? Ah, magical. They're congruent. Vertical angles are congruent, so that'd be 140 degrees. 43 degrees. Easy peasy. All right, see if you can do this bad boy on your own. No, I know it said not to find 1 or 3, but you could find them. 2 and 4, if 4 is y, then 2 has to be y. And 1 and 3 is just 180 minus y degrees, because these two angles add up to 180, and as do these. So to find the missing one, you just take the y away from 180. Now this is a lesson quiz. If you can do this, you're going to be well on your way. So go ahead and do the practice after this, after you check your answers. How'd you do? I want to just say thank you for being here, and I will talk to you soon.